The flammability diagram will vary depending on the type of cargo that you carry and must be provided as part of the MSDS. The purpose of the flammability diagram is to help us maintain the cargo tanks in safe condition. Maintaining cargo tanks in safe condition can be done by maintaining an air-free tank atmosphere with cargo vapor above the LNG liquid, being able to make gas-free the empty cargo tank and to provide sufficient level of oxygen in the tank for man entry when needed. All points on the shown diagram represent flammable vapor, air mixture, and inert gas, specified in terms of its oxygen and vapor content. Mixtures of air and flammable vapor lie on the line PQ, which represents the tank atmosphere, wherein the HC content increases and the oxygen content decreases as you move up the line PQ. The slope of the line PQ represents the reduction in oxygen content when the flammable vapor content is increased. Oxygen content is 10.5% of tank atmosphere at 50% cargo vapor and 50% air. All the points to the left side of the line PQ reflect mixtures wherein the inert gas is added to further reduce the oxygen content. Points R and S indicate the lower and upper flammability limits, LFL and UFL, for mixtures of air and flammable vapor. Below the point R, sufficient hydrocarbon is not available to aid combustion. Above S, sufficient air is not available to aid combustion. The flammable limits change as the inert gas content increases. This is shown by the lines RT and ST. RT and ST converge at the point T. The shaded area inside the loop RTS represents the mixtures capable of burning. This means that there will be no combustion of the vapor-air mixture outside the loop area RTS. You can see from the diagram that as inert gas is added to air and flammable vapor mixtures, the flammable range gets decreased till the O2 content level reaches a point at which any mixture can't burn. Changes in the composition of mixtures in the tank atmosphere are represented by movements along straight lines as shown in the media. When air is added, the line moves towards point P, at which pure air is only available in the tank. When inert gas is added, the line moves towards a point on x-axis corresponding to the oxygen content of the inert gas, at which pure inert gas is only available in the tank. These lines, shown in the media, represent an inerted mixture with concentrations corresponding to point U. If such an inerted mixture is diluted by air, its composition moves along the line UP, entering the shaded area of flammable mixtures. A point V can be determined in the diagram, and the area below the line VP, including the point W, represents the mixtures which will not become flammable even if it is diluted with air. The line VP is the line of critical dilution. However, you can move from mixtures, such as at point U, to another, such as at point W, by adding inert gas. Similarly, there is another line of critical dilution, called XQ, when cargo vapor atmosphere is inerted, or when a tank with cargo vapor is purged. Mixtures in the shaded area to the right of the line XQ may reach flammable condition, but mixtures below and to the left of the line XQ do not go through flammable condition. You may observe that an initial oxygen content with less than X% can never become flammable when purged with cargo vapor. You may also observe that an initial cargo vapor content with less than V% can never become flammable when gas-freed with air. Practically, a safety factor of 2 is followed to take into account errors in perfect mixing, errors in equipment, and so on. Hence, the concentration of cargo vapor, after inerting, should not exceed V divided by 2% before gas freeing begins in the cargo system. Further, the concentration of oxygen after inerting should be below X divided by 2% before the cargo system is purged with cargo vapor. Even if the safety factor of 2 is followed, all efforts should be taken to ensure that the purging and inerting operations are properly carried out, following correct procedures, and using well-calibrated gas detection equipment and other correct equipment. We must always refer to the material safety data sheet of the cargo to find out the flammable range of that cargo.